Today we are in our 7th lecture, and this lecture is all about the concept of return, log return, the normal distribution using the log return in the stock prices, and we will also discuss some of the important factor to know that how we can compute the percentage loss using log returns and the past data. So let us start from the very easy and very basic part. First of all, I am opening this window and I want to discuss the concept of return. So what I am going to know, what is return? In our local language, return means वापसी यानी you have to give back. First of all, let us consider this table, and this is the earning of a boy on day 1, and it is 30 rupees or $30, and on the day 2 he earned from 30 to 40. There is an increment of 10 rupees. So whatever if you want to calculate the return, or if you want to calculate the benefit, you just have to minus 40 minus 30, and you will get to know that on the day 2 he have gained a profit, or return calculated is 10 rupees. So if you want to calculate the return on day 3, you can go to 20 minus 40, and you will get to know that on the day 3 he has a loss of 20 rupees because he came from 40 to 20. This is the simple return, and you can call it as a difference of payment in the 2 days. But today the topic we are going to discuss is not the simple return, but today I am going to calculate, I am going to explain the hidden concept behind log return. So after discussing what is return, is basically subtracting the income of day 2 from the day 1. So I am going to explain what is log return. So before understanding what is log return, I have to explain you first that what is log. So let us start our explanation from the concept of log. So let me move towards the slide, and before going to these things, I want to explain the concept of log. Everyone knows that if you want to calculate the exponent for 3 raised to the power 4, you have to multiply 3 by 4 times. 3 into 3 9, 9 into 3 27, and 27 into 3 is 81. So the exponent 3 raised to the power 4 is 81. So this is the very simple concept, but what is the purpose of log here? So let us do this thing in the form of log by using the concept of log. You just seen 3 raised to the power 4 is 81. Suppose I don't want to do this, but I want to know exactly the opposite of this. Means I want to know that I want to erase this, and I want to know that how much the exponent of 3, how much the raised to the power of 3 will become 81. So we are writing this concept here in a similar way, that I am writing log 381 and I want to calculate this here. So it will tell me that 3 raised to the power 4 is 81. So you can have the concept of log. We can calculate these conversions by using a simple concept or the form of writing logarithm. You already know log base equal power, and on this side here is written equal base and power. So this is logarithm, and with the help of logarithm you can find the exponent by seeing the answer, or you can do the exactly opposite of it using the forms. So what is the exact purpose of logarithm in real world, and what is the exact usage? Professor Carol JM in her YouTube told us that we can find how old is an artifact, how old is this writing which is wrapped under the paper, under the fabric of linen. So carbon 14 is found from this artifact which is wrapped and found in from the hidden site, from the site which is uh, from the site which is thousands of years old. So we can find the carbon 14 decays in the atmosphere, and we know the decay rate, how carbon 14 decays over time, by knowing the value of its radioactive decay rate, and by having the idea of exponential decay, just like we have the idea of the answer 81, we can calculate how old this artifact is by using a known quantity. We can predict, or not predict, we can simply find the unknown quantity. So you can place this example exactly here. So this is the use of log. So I am hopeful that you get the clear concept what is logarithm and how it is scientifically implemented in the modern world. If you want to have more examples of logarithm, you can also find the human body decay. If you find a human body somewhere, a dead body, using some using some elements of the periodic table, and by already knowing the periodic decay rate of these elements, we can easily find how old the body is and how much time the person is lying in that position. So logarithm has a practical use, but we have started our talk from written, then we go towards logarithm and its actual implementation. Now I am moving towards my actual concept, that is log written. So before moving to the concept, I want to tell you the formula of log written. Log written in stock is the logarithm of close price and the logarithm of close price of the previous day. So someone will ask why you are calculating log written, why we calculate, why we do log written. So we must have to ask why we are calculating log written. It is different from simple written because the log written, when calculated in difference or in parallel to simple written, the log written always provide a normal distribution, or in most of the cases we have the normal distribution by calculating the log written. So there, that is the concept, because in the closing price of shares we do not compute the written, we compute the log written. And by using this formula of log written, what we can do, we have the very important concept, and this log written will automatically produce the normal distribution. So let us examine the log daily written of the stock price of Apple. So let us see some part of this video.
We compute log daily return for stock price of Apple. The histogram of return is symmetric and bear-shaped, which is very similar to normal distribution. Hello,
So you have seen that the graph of log daily return of Apple shares is similar
distribution.
to normal distribution. So we will do calculate the log return of the closing price of our Microsoft shares, and we will examine how it is similar to normal distribution. And if it is similar to normal distribution, everyone knows that in the last lecture we have understand the concept of frequency and distribution, and we all agreed on the idea that having a larger number of tiles, having the larger number of coins tossed, or having the larger number of dices on the floor always most of the time approaches naturally to normal distribution. So before going forward, I want to share the case which we are going to solve today. So we want to calculate in this lecture, our target is to calculate the drop in a stock price. But before going to the drop, understand one thing carefully, that we can only calculate the drop in a stock price if we know that our closing stock price is, or the log written of our stock is approaching to normal distribution. If it is approaching to normal distribution, then in the normal distribution we can calculate the drop. So before going towards the concept of normal distribution, I want to share some of the risk management professors' ideas and their bestseller books, and some facts which are going to amaze you. But before going to these things, I want to show you that our stock also the closing prices of our stock and the log return, I want to tell you that our own log return is also approaching to normal distribution. But before going towards the practical, I want to discuss the term black swan. What is black swan? So there is a professor named as Nassem. There is a professor known as Nassem Taleb who wrote a popular book, the bestseller book. The name of the book is Black Swan. What is Black Swan? According to the definition, it is a highly improbable major risk event that diverges beyond what is normally expected. What is meant by improbable? In our Urdu language, improbable means नामुमकिन. ये एक ऐसा नामुमकिन मेजर इवेंट होता है जो एक्सपेक्टेशन से अलग होता है, جو ایکسپیکٹیشن میں نہیں دیکھا جا سکتا. اور یاد رہے نسیم طالب کی ایک کتاب ہے, بیسٹ سیلر کتاب ہے, 2007 میں انہوں نے لکھی. اینڈ نسیم طالب از اے پروفیسر آف رسک انجینئرنگ ایٹ نیو یارک یونیورسٹی ایٹ مینڈون کالج آف انجینئرنگ. یو کین گوگل دا پرسنالٹی. اینڈ نسیم طالب کہتے ہیں کہ ایسا ہمارے پاس ایسا میجر رسک ایونٹ بھی ہوتا ہے جس کا امپیکٹ اور جس کو پریڈکٹ کرنا ہمارے بس میں نہیں ہے, لیکن وہ اس کا امپیکٹ بہت زیادہ ہوتا ہے. اس کی کچھ اگزامپل ایسے لے لیں کہ جنگ چھڑ گئی اور جنگ چھڑنے کی وجہ سے بلیک سوائن آ گیا, اور ایسا جنگ چھڑی اور جنگ چھڑنے کی وجہ سے اکنامی میں ڈاؤن فال آ گیا. تو یو کین find the interview of Naseem Taleb, you can read the book Black Swan, it is the theory. اور یہ بہت معروف پروفیسر ہیں اینڈ ہی ہیز گیون لیکچرز ان مینی یونیورسٹیز, ان مینی فیمس یونیورسٹیز ان دا ورلڈ. اور عجیب بات یہ ہے کہ 2007 میں انہوں نے بک لکھی بلیک سوین. اینڈ کووڈ-19 جو کہ ابھی کچھ سال پہلے, 1 سال پہلے ہم سے گزرا ہے, اینڈ بلوم برگ چینل کو یہ انٹرویو دے رہے تھے, اور انٹرویو دیتے ہوئے انہوں کی بک جو کہ 2007 میں لکھی تھی, انٹرویور نے پڑھا, انہوں نے اپنی بک میں پریڈکٹ کیا تھا کہ there should be a COVID, there should be a virus, there should be a pandemic which will globally take out the world. انہوں نے کہا تھا کہ ایک پینڈمک ہمارے ٹریول کرنے کی وجہ سے جرمز ٹرانسمٹ ہو رہے ہیں, اور ایک پینڈمک آئے گا جو پورے پلانٹ کو اپنی رپورٹ میں لے لے گا اور لپیٹ میں لے لے گا. اور اس انٹرویور نے ان کی کتاب سے وہ لائن پڑھی, اور لائن پڑھنے کے بعد کہا نسیم طالب آپ جو کہتے تھے یہ تو آپ نے 2007 میں پریڈکٹ کر دیا تھا, تو کیا یہ پریونٹیبل بھی ہے؟ تو انہوں نے کہا کووڈ از ناٹ اے بلیک سوائن, کووڈ از ناٹ اے بلیک سوائن, کہ کووڈ جو ہے نا وہ بلیک سوائن نہیں ہے. کووڈ ایک ایسا ایونٹ نہیں ہے جس کو نارملی ایکسپیکٹ نہیں کیا جا سکتا تھا, کیونکہ میں نے تو 2007 میں کہہ دیا تھا کہ جو ہے نا یہ پینڈمک سچویشن اس طرح کی آ سکتی ہے. لیکن ان کا بلیک سوائن تھیوری کیا کہتی ہے کہ اٹ از ایسا ناممکن میجر اہم ایسا حادثہ ہو جائے جس کو پریڈکٹ کرنا آسان نہ ہو, اور اس حادثے کا امپیکٹ بہت میسو ہو. تو یہ اپنے انٹرویو میں کہتے ہیں کہ بلیک سوائن, کووڈ از ناٹ اے بلیک سوائن, بٹ جنگ کا ہو جانا, سیلاب کا آ جانا, سب زلزلے کا آ جانا, یہ بلیک سوائن ہوتا ہے. اس کی وجہ سے بہت نقصان ہوتا ہے, اور یہ ایک ایسا ایونٹ ہے جس کو ہم اپنے فائنینسز میں, اپنے چارٹس میں, اپنے پریڈکشن میں کسی صورت ایڈ کرنا مشکل ہو جاتا ہے. تو اب ہم آگے کی طرف چلتے ہیں. ہم نے ایئرلی جو ہے نا پروبیبلٹی بھی پریڈکٹ کرنی ہے ڈراپ کی, 5% پروبیبلٹی بھی پریڈکٹ کرنی ہے, لیکن یہ کب ہو سکتا ہے؟ یہ اسی وقت ہو سکتا ہے جب کہ آپ کا جو کلوزنگ پرائس کا کالم ہے, جب اسے لاگ ریٹرن اس کا کیلکولیٹ کیا جائے. لاگ ریٹرن کیا ہوتا ہے اس پہ بات ہو چکی ہے, تو وہ نارمل ڈسٹریبیوشن بنا رہا ہو جیسا کہ یہاں پہ بنا رہا ہے. تو اس سے پہلے کہ ہم آگے کی طرف جائیں, آئی وانٹ ٹو اوپن دا پروگرام, اینڈ فرسٹ آف آل, ویری فرسٹ, آئی وانٹ ٹو شو یو دیٹ مائی کلوز کالم آف ڈیٹا سیٹ is also approaching normal distribution or not. If it is approaching normal distribution, the second step is what? The second step is that we can compute that we are going in the loss of 5% in the next day, or we are going to the loss of many percent, 40 to 50% in the whole year. So first of all, we are starting to import the libraries and to read our files. All these files are uploaded on GitHub. Now, the most important thing is here. The most important concept is here. Now I am calculating this thing which is log return. I have made a variable a column log written, and what I am doing, I am taking the logarithm using np.log of the closed column but shifting it to one value, because if you want to calculate the difference from day 2 to day 1, so you have to shift this close value for the second day to 1 above. I have already given the concept in the lecture 3, so it is not be a problem to understand. And here it is the original close column without any shift, so this will calculate the log written and it will make a new column, and this column consists of log written. Now I am running it, and after running it, it is run. Now the second thing is I want to see whether it is near to normal distribution or not. So first of all, I have imported the library named from the sci-fi library. I have imported a function norm. Okay, it is for normal distribution. I will explain it in a very clear way, but before this I want to tell you that I am doing it. Why? Because I want to calculate whether the drop of the share is how much percent. It is 5%, it is 10%, but it can only be done if the log written is close to the normal distribution. And yes, we can see every log written of a stock price is close to normal distribution. But before doing this, I am going to make you write only 3 lines. The first line is to import the library. We have not used the library, right? The second is we have calculated the log written. I have calculated the mean of this log written. Okay, dot mean is a simple function, and this sigma, what is this sigma? I am calculating the standard deviation. But someone will ask, what would you writing standard deviation DDOF is equals to 1? So it is from stack that if you are looking for the standard deviation of the population, okay, if you are going for the standard deviation of the population, you don't have to write you have to write DDOF 0. But if you can going for the standard deviation for the sample, so you have to write DDOF is equals to 1. So I am going for DDOF is equals to 1. Okay, and I have not run the program yet. I have not run the program. I have just calculated the log written and calculated mean and sigma. I have not run this cell yet. But before running this cell, I want to give you some lectures that how we can go for this distribution and how we can know about this. Okay, so before going to read these lines, I want to share some of the lectures related to it. But before going to the lectures as well, let me remove this and let me leave it here. Okay, leave it here and go towards the slides, and I want to show you something about my something in the slides. So I have told you, take difference of log written of close price column and plotted histogram. I have taken the difference, but I haven't taken the plot the histogram. We can calculate the mean and standard deviation of the normal random variable obtained from log written. We have also calculated the mean and standard deviation. But the question is still here and the cell is still here. We haven't run anything. We haven't understand these things as well. We are here. But the question is still persists. How we can find the drop? 5% drop? How we can find the 5% drop? So for finding that how much the stock price is dropping in a day, it is in a day, or our big question is in a year. So for finding how the stock price is dropping in a year or in a day, we must have to know 2 concepts. The one is CDF and the second is PDF. So we obtain the mean and variance of the standard log written. We have already done it. Okay, in estimating the probability of losing more than 5%. So we have done this part only, but this part is still remaining. And what this part said that we have to estimate the probability of losing more than 5%, more than 40%, 20% in a day using norm.cdf. That's why I'm not going on running the cell, because first we need to explain CDF and PDF. So let us move towards the explanation of CDF and PDF first, then we will move forward. So let me thank you and start from this lecture of Krish Naik from YouTube, and he will explain what is PDF and CDF, and after that explanation we will run the cell, we will see the PDF, we will see the CDF, and we will calculate the values. So quietly listen the lecture for the concept of PDF and CDF. So let us see the video from the start, and we can get the concept of CDF and PDF as well.
We compute log data return for stock price of Apple. The histogram of return is symmetric and bell-shaped, which is very similar to normal distribution.
So you can see we have shown the distribution of logarithm, and it is near to normal distribution. Now I have done it for your satisfaction. Now I'm moving towards the another cell and its explanation. Let us start.
We compute log data return for stock price of Apple. The histogram of return is symmetric and bell-shaped, which is very similar to normal distribution.
Hello all, my name is Krish and welcome to my YouTube channel. Today in this particular video we will be discussing about probability density function, and this is a very important concept in statistics. We'll try to understand how exactly it is created, what is the exact use of probability density function, and how does it help us. Now when I go to this probability density function, in my previous section I've already discussed about histogram. So this is how my histogram basically looks like. I've used the feature height and weight in my data set, and this is basically my output. Now I'm just considering weight feature, and I'm am trying to plot all the points in the form of histograms. If you don't know about histograms, just see my previous video in this particular playlist itself. You'll be able to understand. Now histogram in the y-axis actually says that how many points are basically present within this range. Suppose this is between 70 to 80 weight, okay, 90, 100, 110, 120, 130. So here you can see that suppose I say between 70 to 80 weight from this particular thing, you can say that there are 5 values that are present. Okay, between 80 to 90 there are some 10 values that are present. Between 90 to 100 there are around 12 values that are present. So somewhere like this we can basically plot in the form of histogram. Now if I want to convert this into a probability density function, there will be a or you can also say that we are trying to smoothen the histogram. When we smoothen the histogram, we'll be getting a curve something like this. Okay, so when we smoothen it, and this resembles like a bell curve. Now suppose if I have so many points based on a domain knowledge of weight is also a Gaussian distribution. So we are actually getting this kind of bell curve. But that is not what I am trying to explain over here. We are trying to understand what exactly is probability density function. Now as soon as I draw this particular bell curve, this count value will get removed in the y-axis. Okay, now this will say that percentage of the distribution. This y-axis will now become percentage of the population, or I'll not say population, I'll say percentage of the distribution. Now we'll try to understand what exactly it is. So I'm just going to remove all this. Understand that if I consider this point, okay, and this may be between 60 to 70. Suppose if I consider this point, I want to find out the y-axis. It basically says that within this range, what is the total population, what is the total percentage of this distribution that are present in this location. Okay, sorry, it should not be percentage of population, but understand that what is the percentage of the distribution that are present in this particular region. Okay, percentage of distribution basically means how many points. Suppose here are so many points. Within this so many points, what is the percentage of the points that are basically located in this particular region? And suppose I found out that okay, this value is 0.1. This basically indicates that 10% of the distribution is present in this location. Suppose I consider for this particular point over here, I want to find out what is the total percentage of the distribution that is present over here. Now I will combine this region, this whole region. I'll try to combine, and finally I'll find out okay, 0.25 is the total percentage of the distribution that is present over here. And similarly we do it for each and every location. Suppose this is what this y value basically says. Because there are so many confusion still students have that what is actually present in the y-axis. Understand guys, percentage of the total distribution that are present within that particular location. Suppose if I consider at this particular point, then I will try to see this distribution part. Okay, and probably it will be around 50%. That is 0.5. Okay, and when we combine all these things with respect to all these particular points, it will be giving us around 100%. This cannot go more than 100%. Try to understand in that particular way. It cannot go. That basically means it cannot be more than 1. It will be between 0 to 1. Okay, and this is what is a PDF function. This is basically a PDF, probability density function. Okay, now there is one more concept which is called as cumulative density function, which is called as CDF. Right, that is a little bit different when compared to PDF. Understand CDF how it works. Okay, so I'm just going to rub this particular diagram. Now let us go ahead and try to understand about cumulative density function. This is my PDF guys. Okay, now suppose what is CDF? CDF, as the term says, cumulative density function. Okay, cumulative density function or cumulative distribution functions also you can say. Now in CDF what will happen is that suppose for this particular point that I see over here, it is 0.1. Okay, now suppose for this particular point I want to find out what is the total value. That basically means I have to add this 0.1 and whatever value, suppose this is ranging towards 0.25. Okay, suppose this is ranging towards 0.25. Now I have to add this value. When I add this value, the total will be 0.25 plus 0.1, which is nothing but 0.35. Now my cumulative density function will be having a line like this. Okay, because I'm adding these 2 points, and with respect to each and every point I'll be adding, and finally you'll be seeing a curve something like looks like this. Okay, we'll be having a curve, and this is what a curve of a cumulative density function look like. At the end of the time the slope will become a little bit straight. Why? Because the points are falling, these values will become lower, and this is how a cumulative function basically indicates. It is basically indicating. Okay, now you can see over here you'll be able to see 0.35, 0.55, 0.75, 0.85, 0.9, something like that. Okay, now understand, suppose I take 130 and I try to populate or point out over here, and suppose I get 90% of the values over here with respect to this particular point. Now what does this indicate? This indicates that 90% of the distribution in this particular data set is less than 130 kgs. This is what its cumulative density function basically indicates. 90% of the distribution. Because why I'm getting 90%? Because when I plot this particular point over here, I'm getting 0.9 value, right? And this is all added up. You can see that it is getting added up, so my value is basically increasing every time. This 0.1 got added with 0.25, I got 0.35, right? Again, when I go up, that value will also get added, I'll get 0.55, 0.75, 0.8, 0.95 or 0.9. Now this 0.9 basically indicates that, suppose if I plot this particular point over here and I stretch it to the y-axis, it will show us 0.9. This basically indicates that 90% of the distribution is less than 130 kg. That also indicates that 10% of the distribution in this particular weight feature is greater than 130 kg. What a wonderful analysis, right? We are able to understand so many things with the help of cumulative density function and PDF, that is my probability density function. Isn't it amazing? Right? So this is what exactly is CDF, what exactly is PDF. There's a whole lot of use cases with respect to this. This all information is basically analysis, what we say it as exploratory data analysis. So yes, this was all about this particular video. I hope you like this particular video. In this particular video, we'll understood what is a probability density function and what is a cumulative density function, that is CDF. We understood it in depth. We understood each and everything over here. If you have any queries, please do write your queries in the comment box. I would be very happy to help you out. So yes, this was all about this video. I hope you like this. Please do subscribe to the channel if you are not already subscribed. Please share with all your friends, whoever require this kind of help. I'll see you all in the next video. Have a great day. Thank you one and all.
We do not know the real mean and standard deviation.
Now, with the help of Krish Naik, we are very thankful to the Krish Naik that he basically tell us the concept of PDF and CDF, and we are using that concept now in our stock price, the log distribution, the logarithm of our close price column, which is already a normal distribution, which is also referring to a Gaussian distribution. So let us implement the concept of the person of the PDF or CDF to our case, and let us execute the cell we have left before. But before executing the cell, what is the purpose of using or calculating CDF PDF? Let us see the other part of the video by professor from Hong Kong University.
Of this normal random variable, we have a large collection of data return from historic data. We can compute the mean and standard deviation in this collection. They are not the same as those of normal variable, but close enough, as is shown on the right. Then, what is the chance data loss can be more than 5%? First, we will plot the normal density curve for this data return. This pink area is the probability of losing more than 5% in one day. We can use CDF to get this probability, which is 0.5%. Hence, we have 0.5% chance to have a data loss more than 5%. Our goal is to find out how likely that the stock price of Apple will drop over 40% 1 year, which has 220 trading days. We will use another normal distribution to model yearly return. We need to figure out the mean and the standard deviation of a yearly return. We make assumption that the data returns are independent, which is quite wrong, but it can simplify our discussion here. To get the mean and variance of yearly return, we have formulas for sum of variables. We need independence when we compute the variance. If data return is independent, the variance of a yield return is equal to the sum of variance of 220 data return. Again, with non-CDF, we compute the probability and it is less than 2%. That implies there's only less than 2% chance to have yearly loss to be more than 40%. What happened to Apple in 2012 and 2013 is not consistent with its overall performance.
So, by using the PDF, we know that how we can use the curve of normal distribution according to our requirement to find the loss of per day, and how we can make this loss to be calculated for 220 trading days, or what is the probability of dropping over 40% in 220 days. So we are now moving towards our cell, and this is our cell. And before doing all the things, I want to show you the next line. The next line is the density. We have created a data frame, and in this density data frame we have calculated the minimum value and minus 0.01, or you can say as 1% on the left side, and in the max value I am going right 1% on the right side, in order to have the area, because in the example or in the video of the professor of Hong Kong University, we take the ranges from -4 to 4, and in this case we are taking the ranges from minus 0.01 to 0.01 in order to see our values between these extreme points. So we have simply taken the logarithm minimum value and go a little bit of left, and we have taken the logarithm maximum value using the max function and go a little bit of right, and the step size is 0.001%. So norm.pdf, we have already understand what is PDF, and PDF will take the mean value we have already calculated and the standard deviation. So let us plot the histogram of this density and the histogram of logarithm as well, so we can see both of the histograms and the red line and see it as the distribution. You can see there is 0.1 and 0.10 in the extreme end. It is the data, and the curve which is taking the data into its end, but our goal is to calculate the stock price will drop over a certain day. So what we have done in this distribution, we just have taken from this PDF, we are taking the CDF, and CDF, how will a probability drop in 5% in a day, we have used -5 or into 100, you can do it 5%, and the probability of losing a stock price of 5% in a day is very very less. And if someone is asked what is the probability of dropping over 10%, so the probability of dropping 10% is also in front of you. And if someone asks what is the probability of dropping over a year which consists of 220 trading days, so you can see we have written dropping over 40% in 220 days. So this is 220 multiplied by mean calculated, and we have already calculated the mean using the logarithm, and this is the standard deviation. Standard deviation is also calculated. 220 is the number of trading days, and double multiply means exponent. 0.5 means you can say it 1/2 and multiply by sigma. Sigma is also calculated, and the probability of dropping in a year 40 days you have used -0.4, and these two values. Now we can calculate the dropping over 20 days. We just have to change something here, which something is very simple. From this none, I will write here this, and 4 to 20, so drop 20 variable is called here. The probability of dropping dropping is this 20%. So we have calculated the drop in a day, and we have calculated the drop in air, and I request you to perform this practical again and again and see the video. So in this lecture, what we have done, first of all, the very first step, I told you what is written, and after telling you written, I told you what is logarithm, and after telling you logarithm, I told you what is log written, and then I told you how we can calculate log written, and after calculating log written, I told you the fact that the log written, if we calculate, always look like normal distribution. And then we can tell you, if we have the normal distribution, we can compute the drop in a stock price, we can compute the drop or the probability of having a loss, 40% loss in, or a 20% loss in a complete year. So for doing this, I go to the concept of PDF and CDF, and we understand from video of Krish Naik how it PDF and CDF are calculated, and using that concept of PDF and Python, we calculate the drop of 40% in a year and drop of 5 to 10% in a day. And at middle, we also discuss what is block Swan, what is the highly improbable major risk event that cannot be predicted, or that is extremely impossible, extremely difficult to be predicted, but is always have a huge impact. And also discuss the black swan theory of Nassem, Taleb, and we have performed the practical of all the given concept. That this lecture is very important and consists of around a lot of major concepts. So I request you, each and every one of you, to keep this lecture as a very important lecture, and there will be a lot of questions from this in the exams very soon. Thank you so much.